All right. Now, these are what we call compound inequalities. And for the sake of what we're going to do with this and with what we do with absolute values, we want to think of them as, like for number 1 here, you see how it has the word or? This is what we call an or inequality. It's not the technical math term, but that's the term that we're going to use because when we go to absolute values, we need to know if we're going to use an and inequality or an or inequality. This guy right here is an and inequality. So if you take a look at these, you can tell if it says the word or, it's an or inequality. If it says the word and, do you think it's an and inequality or an or inequality? And if it's like 3 parts to it, where you have an expression in the middle, and then you have 2 end points like this, then it's an and inequality. And that's going to make a big difference when we get to our value. Now, to solve this, you solve them just like you would any type of inequality or equation. Now, remember, if we divide or multiply by a negative number, what do we do to the inequalities? You flip them. So we got to keep that in mind. Now, for an or inequality, there's 2 parts to it. There's 2 parts to it. The first part, m minus 2, is less than negative 8. All right. Add 2 to both sides. You'll get m is less than what? Negative 6. So you could go to the number line here. Am I going to use an open dot or a closed dot? Open. So we'll be open at negative 6. And I want all the numbers less than. It's right in between the negative 4 and the negative 8. Now, you take the second part. M divided by 8 is greater than 1. Multiply both sides by 8. Those 8's divide out. I'm left with m, which is greater than, what's 1 times 8? 8. So I go to 8. Is it going to be an open dot or a closed dot? It's a greater than, so it's going to be open. The closed dots are going to be if you have less than or equal to, greater than or equal to. Then you're going to use a closed dot. If it's less than or greater than, use an open dot. Now with the or inequality, you're going to get a graph that looks like this, where you have 2 endpoints like this, and the graph will move in one direction and then the other direction. So that's what the graph will end up looking like for an or inequality. Now, with an and inequality, like this, the nice thing about it, when it's written like this, we want to get n. So we want, let me move that over a little bit. We want n isolated in the middle. So we get a, in this case, is less than n, which is less than b. That's what we want. So we have to use our algebra skills in order to do this. Now, in order to maintain equality, or of the entire, even though it's an inequality, in order to maintain the balance of this inequality, I have 9 plus n here, That's a positive 9, so I'm going to subtract 9, but I'm going to subtract 9 from all three parts. So I'm still going to get less than and less than. There's going to be a negative 10 here. Now 9 minus 9 is 0, so I'm left with n right in the middle. And 17 minus 9 is 8. Now, here's what happens when you graph this. Am I going to get an open or closed dot for the less than? Yeah, that's an open dot. What about for this guy? Open. So I go to negative 10, I put an open dot. I go to 8, I put an open dot. And since n's right in the middle, I'm going to connect right in the middle. And this is the big difference between the or situation and the and situation. Now, if we go down to number 4 here, and we have two inequalities. And it says we want this and we want this. We want where we're going to graph both of these on the same graph, and then our answer is going to be where the overlap actually is, where the two parts overlap each other. So let's take a look at x plus 8 is greater than or equal to 9. If I subtract 8 from both sides, I'll still get x, which is greater than or equal to, where's that from? Okay. What's 9 minus 8? So we get x is greater than or equal to 1. One of each for both of you. So I'm going to go to 1. And I'm actually going to graph just above the graph in this case. I'm going to, it's a closed dot, and I want greater than, so I'm going to go this way. And now, I want to go x over 7 is less than or equal to 1. Now, how do I solve that for x? Yeah, multiply by 7. 7 times 7 is 1, so they divide out. I get x is less than or equal to 7. Now, is this going to be an open dot or a closed dot? All right, so at 7, I'll have a closed dot, and I want all the stuff to the left. Now, where's the overlap? Is there... Basically, when it says and, it has... Whatever our answers are, they have to work for both of them. So they have to work for this one, and they have to work for this one. Now, negative 3 only works in one of them, negative 2 only works in one of them, negative 1 only works in one of them, 0 works in one of them. 1 works in both of them. So I can put a closed dot at 1 for my final answer. I'll use that. And now, over here, I could put a closed dot at 7, and then what I'll do is I'll I'll shade across like that. So if you have something that says and that isn't like this, even though the final graph looks a lot like what we had up here, if it just says and, you have to make sure that you're going to go with the overlap. So we can break it down. Like for number 3, we'll do one more of these. 2x is less than 10. What do I do? Divide by 2. So x is less than 5. So I have to find 5. Is it going to be open or closed? And I want the less than part, so it's going to graph that way. Now I have x over 2 is greater than or equal to 3. Multiply by 2. X is greater than or equal to 6. So I go to 6. Now, is this going to be open or closed dot? Closed. Nope. That's it. That's all you do for this. Thursday.